Hi guys, so we are really diving into our graphing of rational functions, and so I decided to sort of break up the pieces into a few different lessons for you. So if you are in Canvas, you'll find that this is the first lesson, sort of chunk of the lesson for graphing, and we're talking about finding vertical and horizontal asymptotes in rational functions. So to find the vertical asymptotes, what we can do is we can set our denominator equal to 0. So our vertical asymptotes and our domain really have a lot in common with each other. I know I cannot have 0 in my domain, so what I want to do is I want to set my denominator equal to 0, and here I'm going to get x is equal to 2. So I know that my domain is going to be values that are not equal to 2, which in return means that at x equals 2, I have a vertical asymptote. So what I did was I went ahead and I graphed this in Desmos, and you can see here where this green dashed line is that at x equals 2, I have a vertical asymptote there. And so sort of the domain that we found with our function really matches up with the shape of this graph. So here's another example. I'll set my denominator, x plus 2 is equal to 0. I get that x is equal to negative 2. So I know that my domain here will be all real numbers, x values that are not equal to negative 2, or we could say x values such that x does not equal negative 2. There's a few different ways that we can write domain here. So I know that I will then have a vertical asymptote where x is equal to negative 2, and I went ahead and graphed this one in Desmos, and we can see here again that this green dashed line represents that vertical asymptote. And I can see my graph sort of getting closer and closer and closer from the right, and closer and closer and closer from the right. So here's one more. I'll go ahead and set my denominator equal to 0. So x squared minus 9 is equal to 0. I know that this is a difference of two squares, so x squared and 9 are my perfect squares here. So I can factor this accordingly. So x plus 3 and x minus 3. For those of you that aren't familiar with the difference of two squares, it's a squared minus b squared is equal to 0. I can factor this into a plus b and a minus b. So if I have x squared minus 25, this factors into x plus 5 and x minus 5. So just sort of a little side note for some factoring tricks off to the side there. So now I can solve this, and I'll actually end up getting two sort of restriction pieces. So I know that x can't equal negative 3 and positive 3, which means that this example will produce a vertical asymptote in two different places. It will produce an asymptote where x is equal to 3 and where x is equal to negative 3, and I can see that here. Here's my negative 3 asymptote and my positive 3 asymptote. So just sort of a little question for you to ponder and think about, and we really touched upon this through so far in this video, is what's the relationship between the domain and the vertical asymptote? Well, the purpose sort of the vertical asymptote is to show that my domain, that my x values will get really, really, really close to the value that it can't be, but it won't ever actually touch it. So there's a really strong connection between my domain here and my vertical asymptote, and that is that the restrictions in the domain really tell me where my vertical asymptote will be. So here are some horizontal asymptote notes for you, and if you want to go ahead and screenshot this, this will be something that is really helpful for you moving forward. It will be something that I'm sure that you'll reference when graphing and when solving. So this would be a great piece to screenshot. I'm just going to go ahead and sort of explain what I mean by this. There are three sort of cases to where we would have horizontal asymptotes for these rational functions. And you can see I sort of defined my own rational function over here. I have this p of x and I have this q of x over here. So p of x is a function and q of x is a function, and f of x is the function that's created by dividing those two functions. Oh gosh, what a mouthful. So when I'm looking here, it's important to note that for all of these pieces over here, I'm talking about the degree of these functions here. So I'm not talking about sort of the functions themselves, I'm talking about the degree of their functions. So if the degree of the numerator, so of the top function, is larger than the degree of the denominator, then there's no horizontal asymptote. If the degree of the numerator, if the degree of the top is smaller than the degree of the bottom, then very easy, the horizontal asymptote is at the line y is equal to 0. And lastly, if the degree of the numerator is equal to the degree of the denominator, then we divide the lead coefficients of the numerator and the denominator to find the asymptotes. So I know that's a lot of information sort of thrown at you at once. So let's sort of go through these case 1, case 2, and case 3 to get a better idea of what this looks like. So here's case 1. Case 1, so first of all, we can go through and we can look at this and say, oh gosh, here we have this rational function, 2x squared divided by 5x minus 3. I can set my denominator equal to 0 and get that my restrictions are x can't equal 3/5. So I know that I have a vertical asymptote where x is equal to 3/5. And because looking here, the degree of my numerator is 2 and the degree of my denominator is 1, here the degree of the numerator is larger than the degree of the denominator. So this is case 1. So there's no horizontal asymptote. So this has no horizontal asymptote. There's actually an oblique asymptote, and if you're one of the students in this course who's actually enrolled in the honors version, I'll post another assignment and a few more videos for you to take a look at, and we'll talk further about oblique asymptotes in these rational functions. And for those of you that aren't enrolled in the honors course, you're also welcome to sort of take a peek at that, but that won't be a graded assignment for you. So case 2 is the degree of the numerator is smaller than the degree of the denominator. So here this degree is 1, so the degree of the numerator is 1. The degree of the denominator is 2. So the degree of the numerator is 1, denominator is 2, 1 is less than 2. So very easy, there's an asymptote that's located when y is equal to 0. So yeah, here is the other rational, so case 2 for horizontal asymptotes. Looks like case 2 popped up twice on these slides. So here's the picture of what case 2 will look like. Here's my horizontal asymptote here at y is equal to 0, and we can see that we actually have 2 vertical asymptotes here. And there we could solve this if we wanted to, set the denominator equal to 0. It looks like we can't factor this. We could complete the square, or we could use the quadratic formula to solve this to see where those vertical asymptotes actually happen. So case 3 is the degree of the numerator is equal to the degree of the denominator. So here, the degree of the numerator is 2, the degree of the denominator is 2. So since they're equal, we can divide their lead coefficients. And their lead coefficients here are this 4 and this positive 2. So I would say y is equal to 4 divided by 2. So I'll have a horizontal asymptote at y is equal to 2. So here are my notes that I've typed here. Divide the lead coefficients. Here we have a horizontal asymptote at y is equal to 2. And we can see what this looks like in the graph that I pulled from Desmos. So that is it for asymptotes. So just sort of 2 quick reminders. So vertical asymptotes, we're just setting our denominator equal to 0. And horizontal asymptotes, this screen right here is really your go-to. I'll give you another shot to screenshot it. And this is sort of what you should reference back to as you are doing the homework from the book. I think the first few problems aren't having you graph, they're just asking you to find the asymptotes. Good luck, guys.